Since this simple arithmetic involves quantities, the premise of dimensional analysis requires that we multiply both numbers and units. The numbers of these two quantities are multiplied to yield the number of the product quantity, 86, whereas the units are multiplied to yield in times C-min. Just as for numbers, a ratio of identical units is also numerically equal to 1 in equals 1, and the unit product thus simplifies to Cm. When identical units divide to yield a factor of 1, they are said to cancel. Dimensional analysis may be used to confirm the proper application of unit conversion factors as demonstrated in the following example. Example 1.8. Using a unit conversion factor. The mass of a competition frisbee is 125 g. Convert its mass to ounces using the unit conversion factor derived from the relationship 1 oz equals 28. 349 g, Table 1.6. Solution. Given the conversion factor, the mass in ounces may be derived using an equation similar to the one used for converting length from inches to centimeters. Letter 1D465, OZ equals 125 g times unit conversion factor. The unit conversion factor may be represented as 1 oz 28, 349 gon 28, 349 g 1 oz. The correct unit conversion factor is the ratio that cancels the units of grams and leaves ounces. Letter 1D465, OZ equals 125 g times 1 oz 28, 349 g, 12,528, 349 oz 4, 41 oz 3 significant figures. Check your learning. Convert a volume of 345 qt to liters. Answer, 844 L. Beyond simple unit conversions, the factor label method can be used to solve more complex problems involving computations. Regardless of the details, the basic approach is the same. All the factors involved in the calculation must be appropriately oriented to ensure that their labels units will appropriately cancel and or combine to yield the desired unit in the result. As your study of chemistry continues, you will encounter many opportunities to apply this approach. Example 1.9. Computing quantities from measurement results and known mathematical relations. What is the density of common antifreeze in units of g/ml? A 4 qt sample of the antifreeze weighs 9.26 lb. Solution. Since density equals mass volume, we need to divide the mass in grams by the volume in milliliters. In general, the number of units of B equals the number of units of A times unit conversion factor. The necessary conversion factors are given in Table 1.6. 1 lb equals 453, 59 g. 1 L equals 1567 qt. 1 L equals 1000 ml. Mass may be converted from pounds to grams as follows. 9.26 lb times 453. 59 g. 1 lb equals 4.20 times 103 g. Volume may be converted from quarts to milliliters via two steps. Step 1. Convert quarts to liters. 4.00 qt times 1 L1. 0567 qt equals 3.78 L. Step 2. Convert liters to milliliters. 378 L times 1000 ml. 1 L equals 3.78 times 103 ml. Then, density equals 4.20 times 103 g. 3.78 times 103 ml equals 1.11 g ml. Alternatively, the calculation could be set up in a way that uses three unit conversion factors sequentially as follows. 9.26 lb 4.00 qt times 453. 59 g 1 lb times 1.0567 qt 1 L times 1 L 1000 ml equals 1.11 g ml. Check your learning. What is the volume in liters of 10 oz, given that 1 L equals 1567 qt and 1 qt equals 32 oz exactly? Answer: 2. 957 times 10 minus 2L. Example 110. Computing quantities from measurement results and known mathematical relations. While being driven from Philadelphia to Atlanta, a distance of about 1250 km, a 2014 Lamborghini Aventador Roadster uses 213 L gasoline. A. What average fuel economy in miles per gallon did the Roadster get during this trip? B. If gasoline costs $3.80 per gallon, what was the fuel cost for this trip? Solution. A. First convert distance from kilometers to miles. 1,250 km times 0. 62,137 mi 1 km equals 777 mi. And then convert volume from liters to gallons. 213 L times 1. 0.567 QT 1 L times 1 gal 4 QT equals 56. 3 gal. Finally, average mileage equals 777 mi 56. 3 gal equals 13. 8 miles/gallon equals 13. 8 mpg. Alternatively, the calculation could be set up in a way that uses all the conversion factors sequentially, as follows. 1,250 km 213 L times 0. 62,137 mkml. 0.567 QT times 4 QT 1 gal equals 13. 8 mpg. B. Using the previously calculated volume in gallons, we find 56. 3 gal times $3. 801 gal equals $214. Check your learning. A Toyota Prius hybrid uses 59.7 L gasoline to drive from San Francisco to Seattle, a distance of 1,300 km, 2 significant digits. A. What average fuel economy in miles per gallon did the Prius get during this trip? B. If gasoline costs $3.90 per gallon, what was the fuel cost for this trip? Answer: A. 51 mpg. B. $62. Conversion of temperature units. We use the word temperature to refer to the hotness or coldness of a substance. One way we measure a change in temperature is to use the fact that most substances expand when their temperature increases and contract when their temperature decreases. The liquid in a common glass thermometer changes its volume as the temperature changes, and the position of the trapped liquid surface along a printed scale may be used as a measure of temperature. Temperature scales are defined relative to selected reference temperatures. Two of the most commonly used are the freezing and boiling temperatures of water at a specified atmospheric pressure. On the Celsius scale, 0 degrees C is defined as the freezing temperature of water and 100 degrees C as the boiling temperature of water. The space between the two temperatures is divided into 100 equal intervals, which we call degrees. On the Fahrenheit scale, the freezing point of water is defined as 32 degrees F, and the boiling temperature as 212 degrees F. The space between these 2 points on a Fahrenheit thermometer is divided into 180 equal parts degrees. Defining the Celsius and Fahrenheit temperature scales, as described in the previous paragraph, results in a slightly more complex relationship between temperature values on these two scales than for different units of measure for other properties. Most measurement units for a given property are directly proportional to one another, y equals mx. Using familiar length units as one example, length in feet equals 1 ft 12 in times length in inches, where y equals length in feet, x equals length in inches, and the proportionality constant, m, is the conversion factor. The Celsius and Fahrenheit temperature scales, however, do not share a common 0 point, and so the relationship between these two scales is a linear one rather than a proportional one, y equals mx plus b. Consequently, converting a temperature from one of these scales into the other requires more than simple multiplication by a conversion factor, m. It also must take into account differences in the scales, 0 points, b. The linear equation relating Celsius and Fahrenheit temperatures is easily derived from the two temperatures used to define each scale. Representing the Celsius temperature as X and the Fahrenheit temperature as Y, the slope, m, is computed to be degrees F minus 32, F 100 degrees C minus 0 degrees C equals 180 degrees F 100 degrees C equals 9 degrees F 5 degrees C. The y-intercept of the equation, B, is then calculated using either of the equivalent temperature pairs, 100 degrees C, 212 degrees F, or 0 degrees C, 32 degrees F, as letter 1D44F equals letter 1D466 minus letter 1D45A letter 1D465 equals 32 degrees F minus 9 degrees F 5 degrees C times 0 degrees C equals 32 degrees F. The equation relating the temperature T scales is then letter 1D447 degrees F equals 9 degrees F 5 degrees C times letter 1D447 degrees C plus 32 degrees F. An abbreviated form of this equation that omits the measurement units is letter 1D447 degrees F equals 95 times letter 1D447 degrees C plus 32. Rearrangement of this equation yields the form useful for converting from Fahrenheit to Celsius. Letter 1D447 degrees C equals 59. Letter 1D447 degrees F minus 32. As mentioned earlier in this chapter, the SI unit of temperature is the Kelvin K. Unlike the Celsius and Fahrenheit scales, the Kelvin scale is an absolute temperature scale in which 0, K corresponds to the lowest temperature that can theoretically be achieved. Since the Kelvin temperature scale is absolute, a degree symbol is not included in the unit abbreviation. K. The early 19th century discovery of the relationship between a gas's volume and temperature suggested that the volume of a gas would be 0 at minus 273, 15 degrees C. In 1848, British physicist William Thomson, who later adopted the title of Lord Kelvin, proposed an absolute temperature scale based on this concept. Further treatment of this topic is provided in this text chapter on gases. The freezing temperature of water on this scale is 273.15 K, and its boiling temperature is 373. 15 K. Notice the numerical difference in these two reference temperatures is 100, the same as for the Celsius scale, and so the linear relation between these two temperature scales will exhibit a slope of 1 K degrees C. Following the same approach, the equations for converting between the Kelvin and Celsius temperature scales are derived to be letter 1D447K equals letter 1D447 degrees C plus 273. 15. Letter 1D447 degrees C equals letter 1D447K minus 273. 15. The 273.15 in these equations has been determined experimentally, so it is not exact. Figure 1.28 shows the relationship among the three temperature scales. A thermometer is shown for the Fahrenheit, Celsius, and Kelvin scales. Under the Fahrenheit scale, the boiling point of water is 212 degrees, while the freezing point of water is 32 degrees. Therefore, there are 180 Fahrenheit degrees between the boiling point of water and the freezing point of water. Under the Celsius scale, the boiling point of water is 100 degrees, while the freezing point of water is 0 degrees. Therefore, there are 100 Celsius degrees between the boiling point and freezing point of water. Under the Kelvin scale, the boiling point of water is 373, 15 K, while the freezing point of water is 273.15 K 233. 15 K is equal to negative 40 degrees Celsius, which is also equal to negative 40 degrees Fahrenheit. Figure 1.28. The Fahrenheit, Celsius, and Kelvin temperature scales are compared. Although the Kelvin absolute temperature scale is the official SI temperature scale, Celsius is commonly used in many scientific contexts and is the scale of choice for non-science contexts in almost all areas of the world. Very few countries, the U.S. and its territories, the Bahamas, Belize, Cayman Islands, and Palau, still use Fahrenheit for weather, medicine, and cooking. Example 1. 11. Conversion from Celsius. Normal body temperature has been commonly accepted as 37.0 degrees C, although it varies depending on time of day and method of measurement, as well as among individuals. What is this temperature on the Kelvin scale and on the Fahrenheit scale? Solution. K equals degrees C plus 273. 15 equals 37. 0 plus 273. 2 equals 310. 2K. Degrees F equals 95 degrees C plus 32. 0 equals 95 times 37. 0 plus 32. 0 equals 66. 6 plus 32. 0 equals 98, 6 degrees F. Check your learning. Convert 80, 92 C to K and degrees F. Answer 354, 7K 177. 7 degrees F. Example 112. Conversion from Fahrenheit. Baking a ready-made pizza calls for an oven temperature of 450 degrees F. If you are in Europe and your oven thermometer uses the Celsius scale, what is the setting? What is the Kelvin temperature? Solution. C equals 59. Degrees F minus 32 equals 59. 450 minus 32 equals 59 times 418 equals 232 degrees C. Set oven to 230 degrees C. Two significant figures. K equals degrees C plus 273. 15 equals 59. Degrees F minus 32 equals 59, 450 minus 32 plus 273. 15 equals 505. 4K 5. 1 times 102K. Check your learning. Convert 50 degrees F to degrees C and K. Answer. 10 degrees C, 280K.